Okay, welcome. Second session, we had last hour, we had a presentation about blockchain demystified, and in this session with Jennifer, we want to show basically how you integrate. If you have a blockchain or you want to have blockchain, how you integrate that with your existing environments. So that's why we're doing two parts. In one part, I go a little bit over the fundamentals. I don't know if everybody was in the first session. We're going a little bit about what is blockchain and how is it built. And then Jennifer will discuss very nicely and deeply about how you do your integration with CICS and IMS. Okay? My name is Wilhelm Mild. I'm an IT architect working on a worldwide base in integration architectures, presenting on these conferences and shows, but also working with customers in different projects worldwide. So if you're thinking it makes sense, Jennifer and me, contact us if you have any projects in mind and you wanna get some help. So what is blockchain? Let's see what is blockchain, what are the components, and then how we integrate them. When we're looking at the definitions, or when we're looking or trying to define blockchain, what is blockchain? We're talking today about business networks, wealth, and markets. All we need to know is it is complex out there. So these business networks can become very complex. And one example was with a ship bringing goods, bringing products from Asia over to US or Europe. They have 85 pages of documentation of conditions they need to take care, taxes, cross-country, all that. And that's on paper. Or that was on paper. And they were looking for how can I make that simple? Just that that you imagine these markets, and we're in a globalization world today, it can become very complex, okay? So therefore, business networks, it is about connectivity, it is about the participants, customers, suppliers, banks, and all that, and they're coming together. The wealth, the flow of goods has some conditions which don't get simpler these days either. We're seeing this, the last months and weeks, how the conditions might change, and then decisions are done how to do that different. But the services across these network transactions that are taking place, the contracts that are basically influencing how you can do transactions, how you can do business, that's changing, and that is an area where everybody's looking to getting it simpler or getting it even automated. And then we have different types of markets. When we're looking at the public markets with our fruit and our car auctions, the public markets and the private markets like supply chain financing and bonds, totally different market types. And with that, we are there to discuss how can we do things simpler? How can we transfer assets? How can we make businesses simpler? Anything that is capable of being owned or controlled is, in that case, an asset. And this asset, coming from two fundamental types of tangible and intangible. Think of, intangible assets like a bond from financial or patents, digital rights for music. It's a total different approach than if I would have products to ship and have them. Nevertheless, it is important to see how can we do this simpler, how can we do that, how can we accelerate and make it increase trust. So I think the majority of the trends to make businesses simpler is to increase the trust without increasing complexity. So the problem today is that different companies, different enterprises are recording or are using a kind of ledger, book of records, where they record their business processes. And these business processes being recorded in each of the companies, in each of the enterprises, have different formats, have different content. Now and therefore, when they do business to each other, and you see the different colors here, not everybody knows what happened even though they do business in the same context. So the point is, the problem we have today, that's the complexity, that's inefficient, expensive, vulnerable. And if you think of going back in time, how do you find out what happened a year ago, 2 years, 3 years ago? The company doesn't exist anymore. You have no idea. You have no possibility to find out. And therefore, a new solution is wanted here. And the new solution comes with a shared, replicated, permissioned ledger. That means the network, and you see the same entities here, the same peers, how we call them in a blockchain, are having a so-called replicated permissioned ledger. Everybody has a copy of it, and the peers or the blockchain designer, they decide together with the peers what is the content of this ledger, what is the content, what are the data that we want to have in common stored in this distributed ledger. The advantage of having something like that is based on a consensus, that is the agreement between all these peers in the blockchain. It's based on the provenance, the ownership control, to have the right technology, to have the right security in place and enforced to make that happen. The immutability, tamper-proof, nobody can change. Everything is with trust, and the finality, single source of truth about what happened between those entities in the blockchain. So blockchain basically is a private network between different entities, and I call them entities because it can be even in one company. If you have a global company across continents, they might want to see what happened and they want to have it internal. And we have customers that started with that before they went external to make across their industry an implementation of blockchains. So therefore, blockchain is basically to increase trust between business partners without trusting each other and without having a man in the middle. And the man in the middle basically is, as example, a central bank for financial. It's PayPal for us when we buy something and we don't really trust the seller. We're using PayPal so we can get our money back, for example. Or it is government to enforce certain regulations, as examples. Okay? Man in the middle. So the blockchain comes with that premise to avoid mans in the middle, but increase the trust based on technology. Now, when we're looking at or taking blockchain as that technology, it came with a first implementation, and the first implementation was Bitcoin. So everybody that thinks Bitcoin is blockchain is wrong. Blockchain is the underlying technology, and Bitcoin was a first implementation. There are other implementations out there, and one of the implementation we talked today about is Hyperledger. It's a blockchain for business implementation. The major difference between Bitcoin and Hyperledger is Bitcoin is based on a crypto or shadow cryptocurrency, and Hyperledger is not. It is not based on any cryptocurrency. It is a blockchain for business. And that means if companies or if entities are making business with each other and they need to have financials into those transactions, they can introduce that, but the blockchain technology or the implementation of the blockchain is not based on a cryptocurrency. Make sense? If there are any questions, please, let's discuss. So the requirements for a blockchain for business there are 4 pillars. Basically, the participants decide which assets to share. The transaction endorsement, the participants give provable endorsements. Participants are also called peers. So the peers or participants know who they are dealing with. Identity versus Bitcoin, which is public and everybody can participate. Anonymity is there. And we have here privacy and confidentiality. I can only see the transactions I'm participating in. I cannot see the other detailed transactions. But the shared ledger contains the information about them. So basically, I cannot hide any transactions, or I cannot do transactions which are, or I cannot do any transaction and think nobody knows what happened in that consent. So blockchain is basically based on those 4 pillars. Important to know is also that blockchain is not replacing any system of record. It is not replacing your databases or transactional systems. It is basically recording transactions separately in this shared distributed ledger. Make sense? Okay, now let's think if we have a blockchain with the peers, the logistic, city administration, banking, auditor, commercial institution, real estate. They all are based on, for example, different applications, different transactional systems, like CICS transactions. The bank is doing SWIFT transactions based on a certain transactional system. With a shared distributed ledger now, we use so-called channels between the different peers in the blockchain to make transactions. So the transactions are not made as general blockchain transactions. They are made based on a channel. So as you see, we have different peers. Different peers have different channels. For example, my real estate peer has a channel to the city administration and another channel to the bank. The logistic institution has a channel to the commercial institution. So here we see that a blockchain can have many different channels, and one peer can participate to different or many different channels, not just one. Now the conditions that the peer executes on that channel, we'll see that's the chain code. Every time a transaction occurs on the channel, through the peer, the replication happens. So basically it is recorded, but the transactions happen on that channel. Make sense? With that said, what are the components of blockchain then? So one chart here to just introduce the components. One is the most important one, our shared distributed ledger. The next one is the condition when a peer can execute a transaction on a channel, and that's the chain code or smart contract that's running on a ledger. The peer are basically building that network. The membership service authenticates and authorizes, manages the identification, who is part of that network, and manages the permissioned blockchain access. Then we have events, and events are notifications on the blockchain. If something happens, I want to be notified. So with these events, and we will see later on how these events can be used to, for example, interface with my system of record. Okay? System management, create, change, and monitor blockchain components. So these are components that are used or necessary to build and manage a blockchain by itself. The wallet as a user security credentials, and the system integration with the APIs that allows us to interface with existing systems of record, with existing transactional systems, databases, whatever. Any questions here? Okay, now, these were the components. If you're looking at how an application interacts with the ledger, we have a blockchain developer that develops a client application, or we have our transactional system that wants to interface. But what we need is these so-called the smart contracts or chain codes, and that needs to be developed. That's not coming from somewhere. These are conditions when the peer is allowed to do a transaction on the blockchain, on the channel of the blockchain. Okay? Chain code is channel related. And then we have through the smart code, the smart contract or the chain codes have events, so I can emit an event here. If the condition for the chain code and smart contract is given, I can insert into the blockchain, record into the blockchain, or query the so-called world state database, which is giving me the actual the actual blocks, the actual transactions that happen. So basically, that's the interaction database for the user, what happened in the blockchain. Okay? And here, the blockchain itself gives me another event that when something, for example, is added in the blockchain, I can have an action that is triggered in that case. Questions? Now, integrating with existing systems, the possibilities here are bidirectional. So basically, I have a system with events. I have an event on my system, and then I interface with the blockchain. Or I have an event on the blockchain and interface with my system. I can call into the blockchain network from existing systems. That's basically thinking of a transaction. If you're executing a financial transaction or a shipping transaction, you want to record that. After the shipping transaction is successful, you want to record that. And then you interface with the blockchain to record the information, what was done and how it was done. And through the exits, to the emits, we can also call out to existing systems from the blockchain. So if something is inserted, I want to know it. For example, my peer is executing, the transaction to ship something to me. And during that transaction, he updated to the blockchain. And I want to know when that blockchain is updated with that information, so I get informed. So I can trigger some actions in my case. So it's basically a bidirectional possibility of integration and action from blockchain. So therefore, from a client application perspective, you can use the Hyperledger component, Hyperledger Fabric Composer. The Composer is a tool that gives you the possibility to integrate between the Fabric, the runtime, and your business application. Build those APIs, and even run a REST API server. So it connects over the channel to one or more peers. It connects over the channel to one or more order nodes. So this client application has can have different functionalities. It can receive events from peers. Important is I need to develop that interface through a software developer kit or base APIs which are available in the Fabric, or I'm using Hyperledger Fabric Composer. With different languages, I can integrate that, so that's another flexibility. So here we have the Composer, and you see it between your business application and the Hyperledger Fabric. Abstractions for business networks. You can even design your business network, your blockchain, with a Hyperledger Composer, and then define how the interfaces should look like, what interfaces you want to use to which component, and then integrate with your business application. Now, when we're looking at the integration with existing systems of record, one action could be that I need to record some transactions. Some I want, some I don't, or I want to record based on the transaction to different blockchains. Think of, you have a blockchain with your banks, with one or with multiple banks, and you have another blockchain with your partners or suppliers. Typically, it's not necessarily that you have the same blockchain for both, because the suppliers might have a blockchain by their own, and you can participate there. The banks have a blockchain by their own, you participate there, and the insurance companies have another one. So you might have the need to conditionally register the transaction in your system of record to one of the 3 different blockchains. Okay? So there are possibilities to do that, to integrate dynamically with more than one blockchain. Query the ledger for actions in the system of record, that's another another possibility that you can have. And then the events from the blockchain network, like the ledger and chain code, create actions in the existing system of record. So if something happens on the ledger, I want to get notified, and therefore my system of record is reacting based on some actions on blockchain. If payments are made, I want to initiate the shipping, all that, these kind of things, okay? So what options do we have? First of all, you can integrate with existing products or existing process tools that you have available and have implemented. Let's see, you have in your ZOS a business process manager, and there are two links here for business process manager and the ODM tool or ODM product, operational decision manager, how you can integrate bidirectional with those products. If in my business process, I want to, at a certain point in time, I want to record something on blockchain, that's where I interface with BPM. And you have that possibility today, and to integrate then with the blockchain, it's the definition of an additional add-on to your process that is defined already. Vice versa, you can also have BPM to initiate some actions or a process if something changes in the blockchain, so bidirectional again. That's possible with BPM, that's possible with the Operation Decision Manager. So these are products that you might have and you see, and if you want to talk to me after the session about that, I would be happy to discuss that, because we're interested to see if you have a use case or you're looking for a use case to do that. Another possibility, a very flexible one, is Ibm Integration Bus. And Ibm Integration Bus is the possibility to integrate with microservices, with partners, with cloud services, and with blockchains. Because I can have workflows in my IIB. I typically have workflows in my integration bus that define what is this workflow about, what should it do, and where do I change anything, or I can decide, have a workflow that then interfaces with my blockchain and inserts information about a transactional happening or a transaction that happened on the system of record. And the integration bus can sit in ZOS, it can be in Linux on Z, it can be in the cloud, and the interaction between the integration bus is very effective. So we have customers doing that, and they see the flexibility of just adding, and think of you're changing from 1 or 2 blockchains to other 2, so you need 4 blockchains, and you want conditional integration. That's also possible on a functional perspective or on a per request base with IBM Integration Bus. Okay? Last point is the integration with ZOS Connect. So the new development that was done in ZOS Connect, and who knows what ZOS Connect is? Okay. So I don't need to go into the very big details, but ZOS Connect gives you a REST API to your services in ZOS. And the first development was done that you can call from an external source or from an external application services in ZOS through a REST API. Now in the newest update in ZOS Connect, you can do vice versa as well. So ZOS Connect is able to call out to a REST service. So that gives us the possibility that you have, at a certain point in time in your application, a call through ZOS Connect to blockchain to insert something into the ledger. Vice versa, through our exits, that you get called through ZOS Connect as well to the backend. And that's the point where Jennifer now will go through a couple of detailed implementation, how to do that, and where you can use that technology. Jerry.
I understand that MQ can also interface with blockchain as well. Where does that fall into here?
MQ falls into the integration bus. But good question, thank you. Okay, any questions so far? Okay, then we'll see how you do that now in a technical implementation.
All right,
from
thanks,
Jennifer.
Wilhelm.
Thanks.
All right, so I was going to go back real quick, and we'll look at the general architecture. So here we go. Let's go back to this one. Okay, so I want to make sure we all have the same understanding before I dive into how we integrate with CICS and with IMS. And they both are actually going to use ZOS Connect for that connection between blockchain and the backend transaction systems. So we've got our friend, our blockchain developer, and they have written this really great client application. We've got a nice front end, whether it's a web page or a client app, and it has to have some way to talk to the backend, right? So typically right now, if you want to go from a client app to, let's say, CICS or IMS, how are you making those calls? Don't be shy. Anybody? There's not a wrong answer. ZOS Connect is a traditional approach right now. So, and that is a what type of call typically to ZOS Connect? It's a REST call. So we'll see lots of different forms of REST calls. The payloads may be formatted in different ways, but typically right now we're seeing a lot of REST calls come in to like something like CICS or IMS. So the same is true for how you're coming into blockchain at this point. So we typically are seeing a lot of REST where we take the smart contracts and we are using a loopback server to generate a REST API. And then from that you can create a Swagger page and import that into ZOS Connect so we can talk to blockchain through REST, but then CICS and IMS can then take that same API because of the Swagger page they've imported into ZOS Connect and still talk to the blockchain. So you've got your client app talking to blockchain, and then you're going to have CICS or IMS also talking to blockchain. Okay. And the other cool thing that Wilhelm mentioned is our smart contract can generate events. So typically, something like CICS or IMS, they run how many transactions a second? Like 5 or 10, right? Only a few. It's really slow. Yeah, not at all. They're really fast. So are they going to want to wait for something like a blockchain to run consensus and verify the transactions? Or are they going to have moved along? They're probably going to have moved along. So they're going to need something like those events. So they're going to want to be able to maybe record something to our ledger, to our blockchain, use the API to talk to it and record something. Now they may want to know that it's actually been verified and committed to the blockchain, that all the peers have it. So at that point we could generate an event, and something like CICS or IMS could then listen for the event. So they could maybe update their records or record it to their records that yes, this was actually verified in the blockchain as well. Okay, so that's a little bit of how the events will integrate with them. So let's take a look at how we've done that. So I'm lucky to have 2 people in the room who have let me steal their slides. They've done a lot of the integration work, and I've got the privilege to learn from them. So we are going to talk a little bit of how to integrate with CICS first, and then we'll talk with IMS. All right, so our scenario. So we have a car leasing consortium. So I am a vehicle manufacturer. I've created a super cool car. My opinion of a super cool car, let's say it's a Corvette, right? Cool car. Everybody's happy for that, right? So we sell it to the dealership. So pick your favorite Chevrolet dealership. They may work with a leasing company. Maybe I'm looking to lease my car and not buy it, so I am going to be your consumer and driver. In any state in the United States, you have to have insurance to be able to drive that car off the lot. You also usually need it for your bank to approve the lease, or if you do a car loan, if you buy the car, you're going to have to show proof of insurance. Oh, that scrap merchant. That is part of the life cycle, but we sure hope he's not going to be part of my scenario, right? I'm going to take good care of my Corvette. It's never going to get to the scrap merchant. I'm never going to need parts from the scrap merchant. And then overseeing all this, we are going to have a regulator. So we've got quite a few participants in our business network. So I can fetch the vehicle information from blockchain. So how do I integrate with that? And where should we use this information? So when you want to integrate, we've talked about it. You're going to use REST. So it's language agnostic. Doesn't matter what your client app is. Doesn't matter what any app is written in. As long as it will support a REST call, you can use it. So Hyperledger Composer has a REST server that is part of that tool set, and it allows us to have that higher level business abstraction. So we are going to, you could also use the Fabric SDK REST server, or actually as part of the Fabric. So they use your created a REST server based off of what Hyperledger Composer did. And so you could also use that instead if you were not looking to just use the Composer REST server and still be able to use APIs. So if you want to use z/OS Connect Enterprise Edition, you've got to be able to use that to talk to the REST servers. So your mobile app is going to potentially talk to z/OS Connect. It could then talk to the blockchain REST server, and it could also talk to something like CICS. Your mobile app could also just directly call the REST server to blockchain. So your new applications, it's showing various different APIs. z/OS Connect will interface with CICS, IMS, DB2, and MQ. The APIs are discoverable via Swagger. So in a couple of slides, I'll show the API page. That's not a Swagger page, but you can actually get to the Swagger page from that you can import into z/OS Connect to generate what it needs to then create what CICS or IMS is going to need to be able to talk to those that you can put in your COBOL to communicate with the REST servers. All right. So CICS, IMS, and a z/OS application is going to have a comm stub, a communication stub that's going to talk with z/OS Connect EE. And then inside that, you are going to have interceptors that are going to provide functions that are going to be called for each request that arrives. And then that interceptor has an interface. So you can kind of look from down at the bottom, 1, 2, 3, 4, kind of, we've got our Liberty runtime that is z/OS Connect. Then our comm stub, that's going to be the connection between the Liberty runtime and our backend transaction processing. And then the interceptors that are going to allow us to work with the REST. And then the interceptor interface that's extensible. All right. So if we want to fetch car details from a blockchain, so in this case, all of the details for our car are stored in blockchain. So maybe CICS is going to be the manufacturer or something like that. We would need to call the blockchain when creating a policy. So I guess in this case, maybe we're the insurer. We're going to have a API exposed, and we're going to need to create a new front end. So this is an example of a API page from Hyperledger Composer. So you could look down here highlighted as an asset. So we've defined an asset in Composer. That's a vehicle. We could scrap vehicles by a particular color, but we've created different transactions that can be called. And we have the ability to expand this to see how we could actually work with those, what the syntax is going to look like, the different ways we could use it. So in particular, we might want to work with like a particular vehicle ID. So if I own a car anywhere in the world, usually it has a VIN number associated with it that makes it unique, right? So if I want to know Jennifer's Corvette, I'm going to need to search off of that vehicle ID. And then from that, I could get other information about that particular vehicle. So this page from Composer is web-based. You can play with the API calls to see how you would have to format it. It's pretty nice. It allows you to directly communicate with the blockchain. So a little bit of a breakdown. We've got a specific vehicle ID. I can pass that in here. I can use the try it out to get information back about it. So in this case, if I put in that VIN number, I can see my response body, and I can tell it's a Ferrari in zone, it's red. Okay. So now this is stuff I could actually give back to CICS or IMS. All right, so now I've got to use the z/OS Connect build toolkit to generate my artifacts. So I'm going to go from this kind of pretty page, and we don't have a picture of the Swagger document, but you're going to have to go into Swagger, so that way we can make it into something that could then be put into like a copybook, request and response and API info copybook, so we can actually add that to our COBOL programs on the back end, so that they can then communicate through z/OS Connect. So you can see down here the operation ID, our vehicle find by ID, which we saw was an API call. And it's telling you it's a base path of API and the relative path, and it's a get method. And then it's going to give you some structures that you can then use on the back end. All right, so a little bit of eye candy. So if you want to look at your API-specific copybooks generated, you've got an example of your request copybook, your response, and your API info. Everybody can read that totally very clear from the back of the room. So these charts will be available for you to take a deeper look at if you're interested. So we have to copy the 3 copybooks that we have created through the toolkit. You're going to copy the API requester copybook, and you're going to add the variables for calling into the communication stub. So this is documented in our Knowledge Center. So you can see an example of that here. And we need to make some program changes, so we're going to do that here. So create a new paragraph, populate the API request, prepare the variables for calling the communication stub, and we need to check our return code. So if we have success, we'll see some API response, and if not, we need to have some error handling. So some useful links. And for your environment configuration to configure and deploy this, so you got to make sure that your resources are supplied in the ZOS address space, that you have the appropriate resources with the correct names. You got to configure XML server for the API requester support, and you've got to define your API requester folder. And then you need to deploy the requester archive into the API requester folder. So a little bit of work to be done. And then look back at the architecture. And then you can expose the ZOS assets as a REST API. So not only can you talk to your REST API, but let's say you wanted to have calls in, you could actually expose those through REST as well. So people could actually make calls into CICS or IMS. And so you can do some mapping to make that happen. So vehicle ID here, so we could map those to what we need it to go to. So right here is our particular key input field for our vehicle number. And to deploy it, you can go down and click ZOS Connect E and deploy to the server. And so now we could actually go from like a green screen to a web page that's going to make REST calls, and we could actually look up our insurance policy number based off of the customer and vehicle ID and see that we're insuring a red Ferrari Enzo. So kind of cool. All right, who thinks this is totally different for IMS? What do you know? It's really not. Kind of cool. So in the coming shares, and actually in the coming sessions you do with us at IBM, you'll actually see that we're going to go to a single story for this. So we debuted, what was it, last year? Last year at Share, the idea of Immunichain. So Immunichain came from some really cool folks in IBM for this idea. So the idea was that you were going to share immunization records and have permissions set around them, and you could share them on blockchain. So Open Mainframe Project hired an intern, and the intern brought this idea to life. So this debuted at Share last year, I think last summer. So you could actually go back and see a little bit of the session from that. So there's the cool front end for it. So we could actually demo that live now if we would like. But here's really some details of that. And so IMS is integrating with this, and CICS is working on integrating with this, and they will have labs and stuff that you can work with on this. So if you want hands-on experience with integrating this, they're actually going to build around this story, or actually have built around the story. Okay, so if you're tracking immunization records, we have 4 participants in this scenario. So you've got guardians, you've got some overseer of that child. So that guardian can assign the medical providers, and they can assign members, and they can also remove members and medical providers. So basically, maybe you have mom and dad, who are the guardians. Maybe grandma and grandpa also have access. And maybe they typically go to a particular pediatrician, but maybe mom and dad move, and now we need a new pediatrician. So we need to be able to revoke access when we're no longer working with a particular provider. Well, then, of course, you need medical providers. Somebody's got to be able to administer those immunization shots. So that medical provider only has access to children that have been granted to them. So they couldn't just go see anybody's information. They have to be given that permission first. And then, of course, you have your child. So in this case, we actually called it an asset form. Your child is not our asset, but information about them is our asset in this scenario. And you will have an assigned guardian. And once they're 18, they can actually move to be an independent and not kind of controlled by the guardian. And then you can have members. So members could be an organization or a school, but there's somebody that can only read the child's record. So they can't see anybody else's information, but if a guardian grants permission, let's say you've got when you're going to send your kid to kindergarten, you have to show that they have valid immunizations. You could grant the school read-only permission and maybe set like a time limit on it, so they could verify that yes, your child has the proper immunizations. They've got them from reputable sources. Okay, they're cleared to go to school. All right, some of these screenshots will look familiar. So we are going to use ZOS Connect to call IMS applications, and AIMS is going to be an API requester. So we've got our ZOS application. It's going to have a API info in a copybook. It's going to talk to the COM stub from the communications ZOS Connect EE. It's going to work with API requester to go back to the API provider at this point, which is blockchain. So pretty cool here. Kenny Blackman in the room did a really cool job putting some of this together for us. So in this scenario, IMS is going to be one of our medical providers. So hospitals or doctors could actually create their records in like an IMS database. And so they can be granted permission to work with a child. So here's some example of like the transactions of a controller. You could add a guardian or things like that when you first register with the network. As a guardian, it talks about my roles here, some of the transactions I can do here. I can create a new child form. Maybe I just had a child. Maybe I've got older children and I need to update some information about them, or we're switching medical providers. These are all things I can do as a guardian. As a child, or really as a child asset form, information that may be available about me, such as my date of birth or where I reside and who my guardian is. And then if you're member organizations, you can have a member ID, and you may be able to do a list of the immunizations on the child that you have permission to see information about. So I can see like right here, it's a soccer club or it's a camp or public schools, and they have a specific ID to help correlate them, so they're unique. So how does IMS participate in this? So they're going to have transactions. They're going to be able to list immunizations. If I'm a primary care physician for a child, I want to know that I'm not giving them something they've already had, so I need to check that out when I've got permission, so I can read the child's records for their current list of immunizations. And then if I do actually vaccinate them, I can add that immunization there and create an updated record with the vaccine dates and with what I gave them. So in our scenario, this is real. I could pull up the system. So we are running on Linux One, and we're running in an Ubuntu guest. So we're going to talk with the Immunization Web App. So a user can log into the application like the medical provider, and they can run that list command to see what's going on. So when they actually want to do something, so they're going to do an API GET call to the Composer REST server. So to the Ubuntu guest, it's going to return back the block. So whenever the doctor actually wants to add the immunizations, this is where IMS is actually going to talk to blockchain. So the doctor would have logged it, let's say, in the database, and you could actually do a post call then back to the REST server to record that to the child asset. So right now, when you want to integrate with Z, IMS is going to support the call out through the call REST API. So we can do a get or a post. So then we've got the ZOS Connect EE providing our interface to talk to it. So it's going to do a post call to add the immunizations. And then let's say the doctor's really just interfacing with the backend IMS if they wanted to see the list instead of directly talking to blockchain, because they probably wouldn't have the permission, but they would have a peer over here that would. They would actually do a get call to get the list, and they would work with their front end that's going to work with IMS. Okay. So it's all through REST APIs. I was not going to drive into these charts. That's a lot of detail, but Kenny has nicely put together. If you want to go through and see what the properties files look like, the summary reports, and then what the requests look like, you can flip through the charts. They are available to you to see examples of how you would have to modify your code and what you would have generated through the build tool in ZOS Connect. So you could take a look through all of that. So they are all available to you. If you want any additional information, lots of product documentation available to you. So they are all linked through here. And I think that leaves us about 15 minutes for questions, if anybody has questions on how anything works. Kind of makes sense. Totally confusing. Anybody tried? No? Go ahead, Chris. You've tried. I would say Chris has done it. So You guys, I know on the TV can't see it, but Chris in the back did all the heavy-handy work with the CICS part, and Kenny in the back and Susie in the back have done all the work with the IMS side. So big shout out to them for their willingness to explore and make all of this happen.